Hey guys, you did such a great job with um, today's activity, and I hope you guys had a lot of fun playing Battleship in class today. And we're just going to go ahead and move on to relations and functions. So this word relations up here sounds a lot like the word relationship. So what we're going to do is come over here to this box, and you can see that I have some ordered pairs written, except they're without numbers. So what we're going to do is we're going to use the parent-offspring relationship, like mother-child type of relationship, to state the missing element for each one of these ordered pairs, or just each one of the pairs. So let's look at the first one. We know that if dog is the parent, what's the offspring of a dog? We call that a puppy. Aw, cute little puppies. Go ahead and jot that down. And if kitten is the offspring, then the parent of a kitten is going to be a cat. A fawn is the baby or child of a deer. And parent goats have kids, just like humans do. And if the parent is a horse, then the offspring is a foal. So what we were just doing was using the word relation to kind of show the connection or relationship between these animals, the parents and their offspring. But the term relation, in mathematics has more of a specific meaning. In mathematics, more specifically, a relation is any set of ordered pairs. Go ahead and pause this so you can jot that down too. So going by this definition, then that means the ordered pair, I can't write today. Oh my gosh, that's supposed to be a 2. 3, 2 is a relation, because a relation is any set of ordered pairs. 3, 2 by itself, if it's a set, could be a relation. If I had more than one ordered pair, 2 or 3 different ordered pairs, guess what? All of that would be considered a relation. Now, there's a few ways that we can represent a relation. One way that we can represent relations is as a set of ordered pairs. And when we do that, the set is always going to be named with a capital letter. So I'm going to call it A equals, and then we need brackets, and I'm having trouble drawing those. Braces. And we just list out the ordered pairs. So obviously mine's not going to fit in here, but please write small enough so that you can fit a few ordered pairs within the polygon. So I have -3, 5. I'm going to go with 2, 2. If I can close those. OMG, this is not working. Okay, I just tried to fix it real quick. Okay, so we have -3, 5, 2, 2, and 2, 4. And what I want you to do is look at what I did in between every ordered pair. I have a comma in between the ordered pairs to separate my ordered pairs, so make sure you do that. And then after I was done writing my ordered pairs, I made sure that I closed my braces, so do that as well. Okay, and that's how we list the ordered pairs as a relation. We list them as a set. Remember, title your set with a capitalized letter, and this is one way that we can represent a relation. The next way that I can represent a relation here with my ordered pairs is by placing them in a table. And I'm going to have my X, -3, and my Y, getting that from my first ordered pair. My Y is going to be 5. My second ordered pair is saying that the X is 2, my Y is 2. My last ordered pair is telling me that my X is 2, and my Y coordinate is 4. And this is just simply taking those ordered pairs and listing them in a table. I could also take those ordered pairs from my table or from my list and place them in a graph. So I have 2, 2 graphed over here, 2, 4, and negative 3, 5 graphed in the proper coordinates. So I can see that 2, 2, and 2, 4, they're both in, quadrant. They're both in quadrant 1. Negative 3, 5 is in quadrant number 2 because the x coordinate is negative. So that means I had to move to the left from the origin. So in a relation, no matter how I illustrate it, either, by using a table or a graph or just listing it as a set, the first coordinate from every ordered pair, your x coordinates, like here as well, there, and there, those are all going to be part of the domain. So as far as your vocabulary goes, to fill this in, the domain is the x coordinates of the ordered pairs. So when I say, what's the domain? You're looking for the first element of every ordered pair, or the x coordinates from every ordered pair. Now your y coordinates, the second coordinate in every ordered pair, all the y's, those are going to be part of the range. So filling in the vocab for range, that's going to be the y coordinates of the ordered pairs. So if I'm asking you to state the range, then you're just going to look for every y coordinate, every second coordinate in the ordered pairs. Okay, so I had to fix my screen a little bit, but what we're going to do is we're going to take the information that I gave you up here in this section that you wrote down. You should have more information than what you're seeing right now, by the way, because you have your set of ordered pairs in there. You drew your graph in here. So really what I'm just going to be going by is the table, because it was really the only thing I could really make fit for this screen right now. So I'm going to be going by that. And we're going to work in this area right here that says state the domain and the range of the relation A shown above. So we're going to state the domain first. So remember that we mentioned already that the domain is all of the x coordinates from your ordered pairs. So if it's the ordered pair, you're looking at the first number of every ordered pair, or if it's your table, then we're simply just looking at what's in the x. That was the bell. So we're simply just looking at what's in the x column. So the way that we write the domain, that we state the domain, is we use a capital D for domain, equals, so domain is, and we're going to open up some braces there. That looks like a weird ear. So let me kind of rewrite that. There we go. That's a little better. So we're going to open up the braces, and we're just going to list the numbers that are in my x column. So I have a -3, and I have 2, and then I'm just going to go ahead and close it after that. Now, although I do have 2 2's written, I actually only have to write it one time in my domain. So anytime you have repeated numbers, you just list it one time for your domain, or if they're repeated for the range, just one time there. Now, for the range, that's going to get a capital R for range. The range is equal to, again, we're going to open up the braces, and this time I'm going to look for everything in my Y column. And I want to go ahead and make sure that I do have these written in numerical order. So we'll start with 2, even though I see 5 first on the list. Well, I need to start with my smallest number, so that's going to be 2, 4, 5, and I'm going to go ahead and close those braces, and then I have listed the range. So again, anytime you're listing elements for the domain or elements for the range, you want to write those out in numerical order. Any repeats in your X column, you only have to write those one time. Any repeats in your Y column, you only have to write those out one time as well. Now there's another way to represent a relation, and it's called a mapping diagram. Now with the mapping diagram, you'll see that I have two circles, and that's what we're going to use always for a mapping diagram. One circle, the one on the left, is for the domain, and the one on the right is going to be for the range. So you have the left side domain, the right side is the range. And we're going to list what numbers we had in the domain. We're just going to list those. 3 and 2 is what I had. And then in my range, we're going to list those numbers as well. 5, I believe I had 5. I had a 2. And I had a 4. So you remember, your domain is all your x coordinates. Your range is all your y coordinates. And the same way that we just listed them like this here, where, if we had any repeats, we only wrote them one time. That's what's going to happen in your mapping diagram. So because I have the number 2 and it belongs to the ordered pair 2, 2 and the ordered pair 2, 4, I'm only going to write it one time. So because its x coordinate is twice, I really only have to write it one time. There's a very special reason why we have to write it just one time, even if it's a duplicate. Because what we want to do is we want to show the relationship. We want to draw arrows to make a relationship there, make a pair. So -3 we know is paired with 5. 2 is paired with 2 from the range. And you know what? This 2 from the domain is also paired with 4. Now, I always say that 2, in this instance, it's got 2 partners over here. It's got a 2 and it's got a 4. So that relationship, what did I just do? There we go. That relationship is really not going to work out. And I'm going to show you why and what we call that when we have something like this. What we show with mapping diagrams is whether or not something is a function. And when we're talking about functions, whether or not something is a function, we mean that every x coordinate is paired with only one y coordinate. So basically, everything that's in the domain can only have one partner in the range. The x coordinates can only be paired with one and only one y coordinate, and that would make a function. So if we go back to this mapping diagram, you can see, like I said, that the 2 over here, it's paired with 2 and 4 in the range. So this is not going to work. It's not a function because really it's like the 2 is cheating on this 2 with this 4, and anytime there's cheating going on, that relationship cannot function. All right, so let's say I have this relation right here. We'll call it C, and I have the ordered pairs 1, 2, and 3, 4. So I'm going to go ahead and fill in my domain and fill in my range. And remember that your domain is the first number in the ordered pairs. So I have 1 and 3 there, and your range is going to be the second number, 2 and 4. And what I want to determine is whether or not this is a function. And I'm trying to choose different colors here to use. Give me a second. Red. We'll work with red. All right. And we're going to draw arrows to represent these different relationships that are happening. So 1 is in a relationship with 2. 3 is in a relationship with 4. And as you can see, every number, every element from my domain, from my x's, is paired with just one number from my y's. So basically there's no cheating going on over here, which means it's a function. And when something is a function, we can actually tell from looking at the graph. So if I were to plot these points, so the first ordered pair was 1, 2, so over 1, up 2 right there. And then the other ordered pair is 3, 4, so over 3 and up to 4. The other way I can tell that this is a function is because on my graph, every x just has one y partner. So basically, this right here is a function because I don't have dots above other dots, like points right above other points in one column from my x's, basically. Okay, so now let's look at this relation with the ordered pairs 1, 2, 1, 3, 3, 4. So we're going to list out the members of the domain and the members or the elements of the range. So in my domain, the x coordinates, I have 1. I have another 1, but remember, I only have to write that one time. And I see that over here I have a 3. So my domain is 1 and 3. And let's look at the range, which is going to be all of your y coordinates. So for the range, I have a 2, a 3, and a 4. So I'm going to list those in the range circle. 2, 3, and 4. And now we're going to draw arrows to show the relationships between these. So we have 1 is in a relationship with 2. 1 is also in a relationship with 3 there. And 3 is in a relationship with 4. Now remember, in order for this to be a function or not, every member in the every element in the domain can be paired with only one element in the range. And I can see that 1, the number 1 over here, has 2 partners. It's partnered up with 2 and it's partnered up with 3. So that means that this is not a function. And if I graph the ordered pairs 1, 2, 1, 3, and 3, 4 right here, then this graph is going to show me that this isn't a function because I have 2 points that are basically one above the other, that they're basically lined up in the same x coordinate. So that right there is going to tell you not a function. Okay, so let's recap. We talked about what a relation is, and a relation, if you remember and you wrote it down, is any set of ordered pairs. And there's a few ways that we can represent relations as a set. If I can write the word, this is not working for me. As a set, as a table, as a graph, we can show the relation. And even, I'm going to abbreviate here, MP, for, if I can write the P. Oh my goodness, what is going on? That is a terrible P. Hold on. Let me try this again. MP for mapping diagram. So those were the few ways that we can represent the relations, the sets of ordered pairs. And then we talked about determining whether or not something was a function. And something's a function when we have items, elements from the domain that are paired with one and only one member in the domain. Or when something's not a function, it's because something in the domain has multiple partners in the range. And remember I said, if that happens, cannot function. Just like a regular relationship. If somebody has 2 or 3 boyfriends or 2 or 3 girlfriends, it's not going to function. It's not going to work out. All right. So we're going to do some practice activities tomorrow when you come in. So I hope you guys have a great night. Any questions, just write those down so we can go over those in the morning. Bye.